Extraction lecture continued. We're going to do a multiple extraction now. And in this type of question, we already know Kp right here, 2.81. Interpretation, please. The solute slightly prefers the organic layer. Good. That's what that means. We have 576 milligrams of compound C, and we're going to extract it with 4.8 mils of water and 5 milliliters of dichloromethane. So which one of those is the organic layer? Dichloromethane. And what I'm going to do for A, set up A here, I'm going to let X equal the amount of C in the water layer. That's what I'm going to let X represent. So let's set up Kp. We got our Kp. Let's get greedy here. And I get that big equation again. I like the big equation. We're just going to edit. We're going to edit this one, okay? These numbers, don't copy these numbers. They're wrong for another problem here. Yeah, what do I got? Magic hotkeys cheat sheet. Interesting. New version of ChemDraw. All right. So organic layers on top. If X is the amount of chemical in the water layer, how much chemical is in the organic layer? How much compound C? 576 minus X is correct and is the only answer. And what's the volume of the organic layer? 5.0 milliliters. I'll put the milligrams outside here just for clarity. Oh, man. I was just reminded I have trouble reading sometimes. And yes, it was 576. There we go. Thank you. So that's the top layer. And how much of chemical C is in the water layer? Look right above it. X over, what's the volume of the water layer in A? Say it again. 4.8. Yes. Not nice. Units are canceling. All right. Now, ladies and gentlemen, just straight up algebra. Okay? Now, Kp, we're told Kp. Let's not write Kp. What's the number? 2.81. No units. That's a rather large 2.81, isn't it? 36 font. There we go. What are these? 18. 16. Nice. 18 is better. Okay. Just math, guys. I'm doing the right side. I'm going to just say, get rid of that. That over 5 means it's down here, right? Over 5 means it can be written down here as well. And then I could multiply both sides by 5 and put it with a 2.81. Oh, yeah. 2.81. Don't even try to copy until I got the final deal, ladies and gentlemen. 2.81 times 5.00. So I got rid of the 5 by bringing it up there. The X is in the bottom here. The blue X. Okay, it's still in the bottom. Now, with the over 4.8 in the denominator here, doesn't that mean it could have been written in the numerator initially? It does. So that means I could divide both sides by 4.80 milliliters and it ends up down here. Okay. straight algebra here, people. Prereq for this course. Well, prereq for the course to get into this course. So 4.80 and units. I'm just getting rid of the units now because they're canceling out. I knew that from the beginning. And the 4.80 is right there. Somebody please do the math on the left side of this equation here. I will put a big divider here so you know this is a new ball game here. Please give me the number that represents this. It will be a little higher than 2.81, not much though. 2.93 x. I did a couple things. Equal, wow, that's not an x. Equals 576 minus x. Correct? Got smaller. Got pinker. Watch this magic. Tell me how I got to this stage. How did I get there? I added x to both sides. 1x to both sides. Now, give me an x. Just work it out for me. Divide both sides by 3.93. 136.67. And it's not a final answer. Let's just leave a bunch of sig figs. And we already said the amount of C, and we were talking milligrams, right? So I just want to be very clear from the beginning. Let x equal the amount of C milligrams, and now we're reminded that's milligrams. Yeah, the units didn't cancel, really. What do we got? That's it. That is the answer to that question. Part A is done. I just need a little more space, so I'm going to tidy things up a little bit. Because I'm writing kind of big. It's kind of a final answer. Let's bring back the shadow boxes. We love the shadow box. Baby blue, interesting. Okay. So in B, we got the same deal. By the way, you're starting over for B. Whole new ball game. The setup is similar, but not identical. Similar, but not identical. What's the one change if you read B carefully? There's only one of these numbers that changes in B. Uh, 4.8 mils of water stays the same. I extracted twice with 2.5 milliliter portions. Okay, this here is extraction 1. Extraction 1. You're physically going to do a first extraction and then do a second extraction. And our goal is to prove that doing 2 extractions with the same amount of solvent, do you realize if you just do 2 extractions with half the amount of dichloromethane, you're still using the same amount of dichloromethane when you're done, but we're going to get a much better result for X. We're going to have a lot less in the water layer and a lot more in the organic layer if we do this problem correctly. Okay? So we're changing the amount of dichloromethane, correct? Yeah, 2.5 milliliters instead of 5. 2.5. So how does that change the math here? I mean, let's do the whole deal. We just have to edit. Don't copy any of those. They're all wrong. The 5 changed to what? The 5 changed to 2.5. That only change was right here, wasn't it? Doesn't that mean the only change here is half this number? Please just divide 2.93 over 2 for me. I'll do it. 1.465. Is that correct? I don't trust myself anymore. 2.93 over 2. It's good. And then it's going to be 2.465x. 2.465x equals, and then give me a new x. It'll be bigger than this number, but this is only our first extraction. It's going to be closer to 200. 233.67. Yeah. You know, for boxes and stuff, that is a final answer. I don't want to get my colleagues and former colleagues in trouble. So I'm going 3 sig figs on this. It's a final answer. Yeah. This is not a final answer. This is going to be used in the next extraction. Tell me how to edit extraction number 2. You do not start with 576. You're going to start over with this amount between the 2 layers. So copy, paste. All right. And how does that change the math on the right? Let's just go to a 16. We just changed the 576. That's all we changed. Correct? Don't copy the results from before. Yeah, that's right. Number 2, section number 2. 2 point, yeah, we need those. We need that. No, that's right. I know I am confused. I know I am confused. Yes, camera lectures take time. And we need another. First, we're going to be out of room. Story of my life. It's number 2. So this changed to what number? 67. That's what you're extracting now. 233.67. And give me a new X. This time it'll be less than 147. I guarantee it. Whoa, that got small. 6.5. It'll be less than 147. At least I hope so. 94.795, she said. So I'm going to go to 94.8 for 3 sig figs because it's the final answer. Notice I didn't round the 233.67 because that was not a final answer. You would have got multiple rounding error. Now, if I planned this a little better, I could fit the next parts on the same document. Let's try to do that. Hope it doesn't go to pot here. Oh, I don't have my num lock on. There we go. How much room did I buy here? Oh, I have way more room than I thought. Sorry. We're back to our original size. So this is after extraction 2. Remind me what X represents again. The amount of chemical in the water layer. So how much chemical, this is part C, how much chemicals in the organic layer after 2 extractions? amount of C in organic, combined organic layers. Combined organic layers from extract 1 and 2. Do not make your job hard. If 94.8 milligrams is all that's left in the water layer, how much total went into the organic layers? The rest, yes, means the rest from 576 minus 94.8, correct? And say 481.15, and that's milligrams, is that correct? Yeah. Milligrams, bold. And we just go 14 or 16. 16. Okay. Percent extracted, is that the question for C? No. I didn't read my own question. You know what I'm going to do for you? Because your email assignment asks you, what is the percent extracted after the 2 extractions? It does. Trust me. I'm adding that as part E, and I'm going to do it out of order. E. What percentage of C was extracted during part B? Extracted into the organic layers. I'm adding it, and I'm doing it on the right side. So we've done half the work. We figured out what went into the organic layers, and we just got to figure out what percent of the total that was, right? So E right here, this is E, not a 3, and E. So percent extracted equals 481.15 divided by 576 times 100. Don't do that. That's for your calculator. That's not for writing on an exam or anything. Times 100. That's not an X, it's times. And a little under 90. Okay, a lot under 90. 83.5, you said? Okay. And then we can get into C. And C just asks us, oh, here we go again. C asks us, explain why it is advantageous to perform multiple extractions instead of a single extraction. Can you think of any reason why you shouldn't perform multiple extractions instead of a single extraction? Okay, well, we just proved C, you extracted more out of the water layer in B than you did in A. And B was multiple extractions, right? Which kind of implies you've answered the question. Explain why it's advantageous. Well, you get more stuff. There you go. I like it. And D, we're going to actually do a cost analysis. If it takes an extra 15 minutes to perform a second extraction, and oh yeah, she's my best editor lately. She always reminds me I haven't finished answering questions. It's good. Okay. Yeah, it might not be advantageous because there's two things going on here. One, you're doing a little more work. That's going to cost you a little more money. But that's the cost. The benefit is right there. how much more stuff did you get by doing it with the multiple extractions than by doing it with one extraction? That's your benefit. Okay. Now, if your cost is greater than your benefit, I'm going to write that down. It sounds pretty profound. If the cost, which in this case is extra labor expense, right, is higher than the benefit, extra milligrams of C extracted, then it is disadvantageous to do multiple extractions. That's it. All right. And then, of course, the shrinking I did earlier, I should have kept, because I need room. Room for what? To do D. So 28 bucks an hour is what you're spending. Keep that in mind. It's going to disappear. And it's going to cost you 15 minutes. So your extra cost for D, extra cost equals, how do you do that? 15 minutes and it's $28 an hour. You could do that, or you could make it a dimensional analysis problem, with this being a conversion factor that gets rid of hours and gives you dollars. That's how I think about everything. Conversion. Everything's a conversion. Okay, so the extra cost is, how many hours did you spend extra?
15 minutes.
Give me an hour. 0.25. Yes, 15 minutes is a quarter of an hour, everybody. You could have written 15 minutes times 1 hour per 60 minutes and got the same answer with dimensional analysis, which would have been fine. And then I'm going to multiply it by, was it 28 bucks an hour? $1.28 on the numerator per hour in the denominator. Yes, being a good qualified lab worker does entitle you to pay such as that. $20 per hour. And how much are we spending on money, on labor here, everybody? Extra. This is extra labor, by the way. $7 exactly, right? $7. Yep. Sorry, we had a question.
It's not worth it to get it.
Oh, we don't know yet. No, we're finding out when it is worth it. That's the only part of this question. We're finding out where is that cutoff where we should do it or should not. We have to figure out how valuable the chemical is. Needs to be, sorry, not how valuable it is. You look up how valuable it is. You go to your Aldrich catalog and they got prices in there, right? And if it's that's extra cost, what about benefits? What's the quickest way to figure out what's the benefit? The benefit is extra milligrams of C extracted. This is how much was in the water layer doing one extraction with 6 milliliters or 5 milliliters of dichloromethane. This is what's left in the water after doing 2 extractions, each with 2.5 milliliters dichloromethane. So what's your benefit here? You could figure out how much got in the organic layer in part A and subtract how much was remaining in the organic layer in part B and get the same answer as subtracting what was in the water layer in part A minus what's in the water layer in part B. Trust me. 147 minus 94.8. That is your benefit. 147 minus 94.8. There. Equals 147 minus 94.8. What you got? 52. Give me 1 decimal. 0.2. And that's my face is in the way. 14 is good enough. 16 is better. Okay. So the ratio dollars per milligram is the cutoff. So equals $7 for every 52 milligrams. It's 2.2 milligrams. 52.2 milligrams is the weirdest way to get this down here. Watch me use ChemDraw for stuff that would take a lot less time using something else, right? What's that equal when we're done? 13 cents. So we can write down $0.13 per milligram. So you look up the price of this chemical in the Aldrich catalog and say it's 40 bucks for every 3 kilograms. Oh, this is a good exercise. Example. Aldrich price. $1.40 for 3 kilograms. I need to convert that to dollars per milligram. So
divided by
you're doing that again. I like the C word. I never like the D and the M word. It's always a conversion factor, okay? The conversion factor. I need to convert this to dollars per milligram. So you copy it out like you see it. $40 for 3. Can I go to 3,000 grams to start? It's already got it. I did a conversion already, but I'm clearly not done. I got to multiply it by something that gets rid of grams on top. It's the best part of chemistry. Trust me. Some with grams on top, grams and milligrams on bottom. Which one's the bigger one? A gram or a milligram? Gram gets the 1 because it's bigger. How many millis in a gram? So 40 divided by 3,000. Did I do this right? Grams are gone? Wow. What's this price of this thing is a lot less than $13 per milligram. It's not. Give me, it's got a lot of zeros. Doesn't it?
Yeah.
How many? 3?
So it's 1.3 times 1 to the
Yeah. Don't do 2 extractions. That's your decision. Okay? This is extra. This is not part of this question. This is a new and improved question down here.
You're going to post this on YouTube?
Of course. And then he asked if this was being posted on YouTube, and I said, of course. This is extra beyond this question. So I looked up chemical C in Aldrich, and I got this price. And it's dirt cheap. We just found out. Look at it's only $0.000013 per milligram. Our stuff needs to be at least this valuable, 13 cents a milligram, to justify doing any extra work. Got it? That's the meaning of that result from part D. Okay? If your stuff's not that valuable, you're not doing the extra work. If it's more valuable than that, yeah, and the very logical thing is that stuff's so cheap, you should have just bought it instead of extracting it. Nice answer, thanks. All right, so there you have it. You have more than you need to answer your email question now. And there we go.